Now your next point is about binomial distribution for the probability. In the earlier section we already discussed just a probability distribution. Now this is a special type of the distribution which is known as binomial distribution of random variable x for the probability. Now the word itself suggests that you have some connection with 2. Now you see when there are only 2 possible outcomes in any single trial, only 2 outcomes in a trial, that is in a single experiment, like this, head and tail when coin is tossed once. Then if you select some unit, you may have defective and non-defective, defective and non-defective, so 2 outcomes. If you select some integers, maybe even or odd, again 2 outcomes. Fine. So in a single trial, when we have only 2 outcomes, and if number of trials equals to finite, then we can use this binomial distribution. Now here in a binomial distribution, normally these 2 outcomes are called here success. We call that as a success, and the other one which is not success, which is called here failure. So every time we have such 2 outcomes, one we call the success, the other one we call what? Failure. Okay. Normally probability of the success is taken as small p, here it is small q. So obviously in a single trial, if there are only 2 outcomes, then you must have p plus q equals to 1. That's quite obvious. Fine. So if we have some finite number of trials, say 10, 20, 30, finite number of trials, each trial has 2 outcomes. Each trial has 2 outcomes. How many outcomes? 2 outcomes. Each trial has 2 outcomes. And trials are independent. Trials are independent. That means second trial does not depend on the first trial. Trials are independent. Then such trials are called here Bernoulli trials. These are sometimes called Bernoulli trials. The word Bernoulli you already come across earlier. Bernoulli trials. Bernoulli trials means what? Number of trials must be finite. Each trial has only 2 outcomes. We call them as success and failure, and trials are independent. If number of trials satisfy these conditions, then such trials are called which trials here? Bernoulli trials. So if you toss a coin, for example, 100 times, that is the example of Bernoulli trials. Number of trials finite, each trial has 2 outcomes, and tossing a coin in a single trial is obviously independent of the first trial. Fine. So these are called Bernoulli trials. Now when we have such trials like 10 trials, 20 trials and so on, then we use one formula that's known as formula for binomial distribution. So we start with like this. Here let x, which is a random variable. Okay, we take small x, which is a random variable for us. So let me write like this. Let here what I should write, x equals to x, that is number of successes. Here number of successes. So this is the definition of random variable, number of successes. In how many trials? In n trials. Number of successes in n trials. So number of trials equals to n. You are performing an experiment how many times? N times. Number of trials equals to x. With the condition that probability of the success equals to small p, and the probability of the other one, that is 1 minus p, you can see, that is failure here, which is q, and q is always 1 minus p. If this is 1 by 3, then this has to be 2 by 3. Then here we have ready formula, probability of random variable x which is equals to small x, is given by your NCX. Now this is a binomial theorem. Very simple formula. We have p raised to x, p is the probability of the success, into here q raised to, that you know, the sum of these two is always this number n minus x. Right? The probability of number of successes is given by this expression. Where what about x? So number of successes in n trials. It is quite possible there may not be success. Suppose you are asked for head and every time you are getting tail in 5 trials, for example. So number of successes may be 0, then maybe 1, then 2. And you are doing for how many trials? N trials. The maximum successes is n here. Fine? Maximum successes will be n. Why x equals to 0? That means number of successes in n trial is 0. What is the meaning of this? Suppose you are tossing a coin 10 times. You have defined success as a head, for example, and every trial you are getting tail. That means number of successes for head is 0. Suppose you are getting 1 time, 2 time, and maximum n times. So this is called the binomial probability distribution for random variable x here. You know, the formula is also easy to remember. NCX into p raised to x into q raised to n minus x. What is q? As I told you, it is always 1 minus p, because in every trial you have just 2 outcomes, remember. Right? That's important. Then and then binomial distribution should be used. In every trial we have how many outcomes? Just 2 trials, and therefore if we call the probability of one as p and the other one as q, then here p plus q must be 1, and therefore q equals to 1 minus p. So what's the probability for random variable x? NCX. This is that combination symbol. P raised to x into q raised to n minus x, where x varies from 0, 1 to up to n. And sometimes binomial distribution is denoted by this symbol. It is denoted by b, then inside the bracket we write n, and here we write small p. What is here n? Number of trials. What is p? Probability of a success in a single trial. What is p? This is nothing but the probability of success in a single trial. Success in a trial. And n, you know, number of trials. Fine. So this is a symbol. Once you know n and p, these are called sometimes parameters of the binomial distribution. Once you know n and p, q you know 1 minus p. And you can find the probability of random variable x from 0, 1 to up to n. So we use effectively this exercise, this formula in the next exercise. Just in every question you need to see what are the 2 trials in each outcome. Remember, this word is very important. In a single trial you need to see what are the 2 outcomes. One you call the success, that is something which you are asked, and the other one we call as the failure. Suppose you are asked for probability of non-defective unit, then we call the non-defective unit as a success. If you are asked for probability of getting tails, then we call the tail as a success, and so on. So let us go to next exercise. You will realize number of questions of earlier exercise also you can do with the help of this binomial distribution. So here exercise 13.5. Very simple exercise you will see, because you have ready formula, nothing you have to think. Question number 1. Every time what I'll do, I'll think for n and p. Finished. That's all in all about solution. A die is thrown 6 times. So number of trials equals to 6. Getting odd number is a success. Okay. So what's the definition of success here? Your x is nothing but what? Getting odd number. Random variable. Random variable is getting an odd number. But remember, this is odd number in a single trial. Okay, so this is success. What's the success here? Getting odd number in a single trial. Can you tell me what's the probability of getting odd number in a single trial? It is obviously 50%. So what is P here? Probability of success. Probability of success, that is equals to P equals to, you know, half, right? That you know very well. And therefore what is Q? That is 1 minus 1 by 2, which is again half. Fine. So here why half? You know what are the total outcome? 6. Odd number means 1, 3, 5. So you have 3 by 6, which is 1 by 2. Okay, so we have Q equals to this, P equals to this. See, what are the possible values of x here? Where x, you know, where let me write x equals to xi, or small x equals to either 0, 1, 2, 3, 4, or max 5 and maximum 6. Fine? Okay, now look at it. First question. So I'll write the required probability equals to, what is the first question? Look at there. What is the probability of 5 successes? 5 successes means what? X equals to 5. Fine. So probability that x equals to 5 here. This is the question. Okay, so I'll use the binomial theorem here. I mean binomial distribution formula. NCX. This is the formula. NCX into P raised to x into Q raised to n minus x. So here n means 6. 6 C5 into P means half. What is P? That is half. Half raised to 5 into 1 by 2 raised to here 1. Okay. So what is 6? Now you need to simplify this. What is 6C5? You know it is 6C1, and which is just 6. This is 2 raised to 5 and 2 raised to 1. So 2 raised to 6. So here your final answer will be, you know, this is 64. 6 by 64. So we'll get the 3 by 32. That's the required probability. Probability of getting exactly 5 times odd number, which we called as a success. When dice is to 6 times. I hope you are clear with this. You need to ask 2 questions to yourself. What is n? What is definition of success? And what's the probability of success in a single trial? Once you know this, you have P, you have n, therefore you can get the Q, and you just place into the formula. So you are almost through in the entire exercise. Okay, now next question. What is the next question? Let's read that. Second sub question. There you are asked for, what you are asked? Probability of getting at least 5 successes. So here required probability equals to probability of x, where x must be greater than or equal to 5. At least 5, that is 5 or more than 5. And here you can write P of 5. Maximum you have how many successes? Look at there. Maximum you have 6. It will have P of 6. Number of successes equals to 5. Here or more. So you have P of 5, P of 6. Maximum is 6. Now you know what is to be done. Now just use the binomial distribution formula. NCX, that is 6C5P. 1 by 2 raised to this number. Q is again 1 by 2. Summation is always 6. So this has to be raised to 1. Then 6C6. What about this? 1 by 2 raised to 6. And here it has to be 1 by 2 raised to 0. Because the summation has to be this number. Okay. So 6C5 is same as 6C1, which is just 6. As we did there, this is 64 plus this is 1, and this is again by 64. Okay, so what we'll get here? 7 by 64. The third sub question here, you are asked probability of getting at most 5 successes. So required probability equals to probability where x is maximum 5. Fine. Maximum success is 5. So this means, you know, it starts with 0 always. We already mentioned it earlier. Success starts with 0. You know here it starts with 0 always. That we know. 0 and so on up to n. So P of 0 plus P of 1 when success is 2 plus P of 2 plus P of 3, P of 4 plus P of 5. Now you know that sum of all the probability equals to 1. So this you can rewrite as here 1 minus which one here 1, that is plus P of 6 is 1. So 1 minus P of x equals to 6 here. Can you recall this? Sum of all the probabilities sigma of x equals to xi is always 1. This is always true for any distribution. Here especially we have binomial distribution. So P of 0 plus P of 1 plus P of 2 plus P of 3, P of 4, P of 5 plus P of 6 is 1. And therefore, actually you are asked for this much. So it is same as 1 minus probability for random variable x equals to 6. This is easier way than this complicated expression. 1 minus, now write the formula for this. 6 is 6, P, which is half raised to 6 into Q, which is again half raised to 0. So this is 1 minus here 6 is 6. What is that? That is 1. And this is 1 by 2 raised to 6. So which is 64. So 1 minus 1 by 64. So this will be 63 by 64. I hope this is clear to you with this concept. Sum of all the probabilities of random variable is always 1. Actually you are asked for at most 5, that is maximum 5. So you need this. So it is as good as 1 minus when random variable is 6. Fine? That we have used, and then just we have placed the formula. Okay. Let's see next question. What is next question? The second question, you see a pair of dice is thrown 4 times. So number of trials, a pair of dice. How many times? 4 times. So n equals to 4. Number of trials. 4. Okay. Every time what we'll ask, what is the success? Getting a doublet is considered as a success. Doublet means what? 1, 1, 2, 2, 3, 3, 4, 4 and so on. So here what is the definition of success? That is nothing but what? Getting what? A double. Getting a double. Right? That is this one. 1, 1, because you are throwing a pair of dice. 1, 1, 2, 2 up to 6, 6. This one. Fine. This is your random variable x. Here x, that is a success, which is this. Small p. Small p means what? Probability of the success. Total, when pair of dice is thrown, you have 36 outcomes. Out of them, how many are favorable? 6. So probability of the success is 1 by 6. So p is 1 by 6, and therefore what is q? 1 minus 1 by 6, which is 5 by 6. Sum of these two is always 1. Okay. Now what we do? Now we go for question here. What's the question? Find the probability of 2 successes. That means x should be 2. Okay, so here therefore required probability equals to probability when x is 2. You know x varies from where to where? 0 to 4, because maximum you have 4 trials. Okay, what you are asked for 2 successes. Read the question, you will realize. For how many successes? 2 successes. Okay, so let's write the formula. What's the formula? 4C2 into probability, that is 1 by 6 raised to 2 into q, which is 5 by 6 raised to how much? 2. Fine. X equals to 2 here. So 4C2, 1 by 6 raised to 2, 5 by 6 raised to this one. Now what is 4C2? You know 4 into 3, 2 factor will get cancelled upon 2. This is 5 squared, and what about this? 6 raised to 4. It is nothing but 6 raised to 4. Now let me simplify a little bit. This is 25. Here we are getting just 6. So 1 6 will get cancelled. 25 upon 6 cube. Right? And what is 6 cube? It is nothing but what? It is 216. So this is the required probability of getting 2 successes here when dice is thrown 4 times. Let's see third question. Now you must have realized you need to ask for 2 questions to yourself. What is n? Number of trials. And what's the success and what's the probability of the success? You can see that 5% defective items in a large bulk of items. Okay. What's the probability that a sample of 10 items? So number of trial equals to 10. Will include not more than one defective item. So what is the success here? Definition of the success, that is X, which is defective item. That is your success. Defective item. Fine, because you are asked for probability of defective item. You can see you have here 10 trials. So this is 0, 1, 2 up to 10. These are the possible values. What is small p? That is the probability of the success. How much item you will find defective? 5%. So 5%, which is 5 by 100, which is just 1 by 20. So p is 1 by 20 and q is here 19 by 20. We have this. Okay, now what is asked in the question? Probability that a sample of 10 items will include not more than one defective. Right? So let me write here required probability equals to probability of X. This is not more than one. What is the meaning of this? One से ज़्यादा नहीं होना चाहिए. That means either it is 1 or less than or equal to 1. This means not more than 1. Not more than 1 means what? Either it is 1 or less than 1. Now what is this? Random variable always starts at 0. So either p of 0 plus p of 1. Now simply you need to put the formula 10c0 into p. P is 1 by 20 raised to 0 into 19 by 20 raised to how much? 10. Plus here we know 10c1 into 1 by 20 raised to 1 into 19 by 20 raised to here 1. So this should be 9. Okay, what is 10c0? 1. What we'll get from this? You can just write here how we can write. This is 1. So 19 by 20 the whole raised to 10. 10c1 always 10 into, what about this? I'll keep 1 by 20 as it is here, and this is 19 by 20 raised to 9. So you can find, if I simplify further, 19 by 20 raised to 9 you will find common. So here you are left with 1 power, that is 19 by 20, plus what about this? Here you are left with 10 by 20. Okay, I'm not cancelling, I'm not writing 1 by 2. So here you have 19 by 20 the whole raised to 9 into, what about this? This is nothing but the 29 by 20. That's a required probability. Probability of getting not more than one defective item out of sample of 10 when there is a 5% probability for defective items. So this became a success. I hope once you do up to this, almost you are through. This is simple algebra, which you can do very easily. Up to this, it's important. Number of trial, what is success, what's the probability success, and then the formation of the question. Fine, let us go to next question now. What about next question? 5 cards are drawn successively with replacement from a pack of 52 cards. Okay, right. So how many trials? 5 trials. Number of trials equals to 5. Let me start with that. So I'll write first number of trials here. Question number 4 here. So here number of trials equals to 5. Okay. What is the definition of success? That depends upon the question. What is the probability that all 5 cards are of spade? So in a single trial you are going to take 1 spade. So here definition of the success, that is nothing but x, which is nothing but getting a spade. Getting what? A spade. You know, in binomial distribution, we always think about a single trial, getting a spade. How many spades are there? You know, 13. Okay, so here small p, that is probability of getting a spade in a single trial. You are just selecting one card. Read the question. 5 cards are drawn successively with replacement from 52 cards. So 13 by 52. There are 13 spades, you know, 13 spades. Favorable outcomes will be 13 and total 52. So this will be just 1 by 4. Spade, club, diamond and heart, you know, 25% chances. Okay, and therefore what is Q? That is 3 by 4. It has to be 1 minus 1 by 4. What are the possible values of x here? X starts with 0 and maximum 5 trials. 1, 2, 3, 4 and 5. Okay, which we know now very well. I hope now you are clear. Let's look at it first question. All 5 cards are spade. That means all 5 cards are spade means what? X should be 5. This one. So answer to the first question here, I'll write required probability. That is the probability of the event that all 5 cards are spade. So x is 5 here. Now write the formula. What is the formula? You know formula is this: NCX into P raised to x into Q raised to n minus x. Okay. So here n, number of trials, 5C5 into P. What is P? That is 1 by 4 raised to 5. This number will go in power. 3 by 4. This is always this number, sum of these two. So the one has to be 0. Which we know now very well. Okay. So what we'll get here? 1 into 1 by 4 raised to 5. So this will be, you know, you have 1 by 2 square, 2 raised to 10, and you know 2 raised to 10 is 1024. So that's required probability. Fine. So simple now for us. Second one. What's the second question? Only 3 cards are spade. Okay. So their required probability, only 3 cards are spade means what? X must be 3. So P where X is 3. Now place the value here, 3, 3, 3. So you can do this. I'll not be doing for you. Third one. What is third question now? Sub question, none is spade. None is spade means what? What should be the value of random variable x? That has to be 0. There should not be a single success, because here spade is a success. The x has to be 0. So in the third question, required probability equals to probability when x is 0. So again you can use the formula. You have 5C0. What is P? 1 by 4 raised to 0. What is Q? 3 by 4 raised to, this summation should be this, so it has to be 5. Just simplify, compare with the backside answer. Clear? Fifth question. Find the probability that a bulb produced by a factory will fuse after 150 days of use is 0.05. So this is probability of something. Find the probability that out of 5 such bulbs. Okay, so number of trials equals to 5. Look at the questions at the end. Will fuse after 150 days here. Okay, so what is success? What is here success? Which is x. That is what? Bulb will fuse after 150 days of use. Okay, fine. So here what are the possible values of x? You know 0, 1, 2, 3, 4 and maximum is 5. What is success here? That's a x equals to this, and therefore what is small b? Probability of the success. You are given ready 0.05. That's given to you. Fine. So this is just 5 by 100, which is here again 1 by 20. So what is q? Has to be 19 by 20. Okay. So you have p, you have q. Okay. So Now I'm sure it won't be difficult for you. What is the first question there? Find the probability that out of 5, none of them will fuse after 150 days of use. What's the meaning of this in the first sub-question? In the first sub-question, required probability, none of them means what? Not a single one. That means probability when x must be 0. Probability of random variable x must be 0. Now we'll use the straightforward formula. What's the formula? 5cx, x is 0. P, what is P here? P you know, it is 1 by 20 raised to 0. What is Q? 19 by 20 the whole raised to this number. Sum of these two always this. What is 5c0? It is always 1. This is 1. So 19 by 20, that is the whole raised to 5. That's your answer. No need to simplify further. You can leave in this form. Okay. Let's go to second question. What about the second question there? Question number 2. Probability of not more than 1. Okay, so that you know. So here required probability equals to probability that x has to be less than or equal to 1. Not more than 1. So either it is 1 or less than 1. Now what is this? This is when x is 0 or maximum is 1. So here 1. Now write the formula. Here 5c0, 1 by 20 the whole raised to 0 into 19 by whole raised to 5 plus here what about this? 5c1, 1 by 20 the whole raised to 1 into 19 by 20 the whole raised to how much? 4. And this we did in the previous example only. You can just simplify. This is 1, this is 1, so this is 19 by 20 whole raised to 5. Plus, what about this? This is just 1. And this is into 1 by 20. Into 19 by 20 the whole raised to 4. Now this is simple algebra. You can take this much common and you can simplify. Smaller power is 4, here 5. So take that much common and simplify. Okay. What about third question? Probability of more than what is that? More than 1. Okay. So in the third sub question, required probability equals to probability when x must be more than 1. More than one such bulb in a random variable drawing out of 5. Okay, more than 1. Now what is this? This is P of 2, P of 3 plus P of 4 plus P of 5. Maximum is 5, we know. Okay. Now it is as good as you know. You can write here. If I write here P0 plus P1, so then you can write 1 minus. You just get x equals to 0 plus P of 1. Why this? I'll just again remind you. If you remember, summation of all the probabilities for random variable is always 1 because it's a probability distribution. So if you start with P of 0 plus P of 1 up to P of 5, it has to be 1. Therefore, we have this. Okay, this is just to remind you. Now this is previous question. Look at it previous. So you can just you can put the value from there and you will get the final answer. Up to this it is important how to form the question. Okay, so now let's go to next question. Okay, see this question. A bag contains 10 balls, each marked with one of the digits from 0 to 9. Okay, so here marked with this, marked with 0, 1, 2 up to 9. There are total 10. If 4 are selected successively with replacement from the bag, so number of trials equals to 4, and you are doing with replacement, so events are independent. So these are Bernoulli trials. Okay, what's the question? What is the probability that the none is marked with 0? So we take here success as a random variable x, that is ball marked with 0. Ball marked with 0. So what is the probability of getting 0 out of this? Obviously, here that's the probability of the success. 0 is just one number, there are total 10, so 1 by 10. And therefore Q has to be how much? 9 by 10. Is this clear to you why probability of the success is 1 by 10? 0 is just one outcome, and total how many outcomes? 10 outcomes in a single trial. That's important. What's the probability of getting 0 from 1 to 0 to 9? 1 by 10. For any, what's the probability of getting 1? 1 by 10. That's obvious. Okay. Now, what is required probability here? Required probability equals to probability of the random variable x. What is that? It has to be what? Probability of number ball marked, no ball is marked with 0 out of this 4. So x must be what? 0. Right? If you take x is equal to 1 here, that means you have one ball marked with 0. What are the possible values of x here? 0, 1, 2, 3 and maximum is 4. Number of successes here. X is this. Okay. Now just write the formula 4C0 into probability of success 1 by 10 the whole raised to 0. This number go there. 9 by 10 the whole raised to 4. 4C0 is always 1. This is also 1. So you have just 0.9 raised to 4. That's required probability. You can just live like this. No need to simplify further. 7th question. 20 questions of true-false type are asked in an examination. Suppose a student tosses a fair coin to determine his answer to each question. If the coin falls head, then answer is true. Okay. Falls tail, then answer is false. Find the probability that he answered at least 12 questions correctly. Okay. How many number of questions are there? 20. So he is doing trial for 20 questions. What is success here? Definition of success, that is x based on the question. What is asked in the question? Probability that he answer at least 12 questions correctly, right? So here x is number of questions asked correctly. Number of questions, answer correctly. Number of question, answer correctly. Okay. So here you know x can be 0, 1, 2 up to 20. We know it. Okay. Now what's the probability of the success? That is small p. That is probability of getting answer correctly in a single trial. When the answer is correct, when head is obtained in a single trial. So what's the probability of getting head in a single trial? Half. This is nothing but what? Probability of getting H, getting head in a toss of a coin. Right? This is given in the question itself. Just read it, you will realize. Okay, and therefore Q has to be again half. So now question becomes very simple for you. So here required probability equals to, what's the required probability? That probability when x at least 12 answers correctly. So x must be greater than or equal to 12. That is number of correct answers is 12 or more than 12. Right? At least 12 means what? Number of correct answers is 12 or more than 12. So here let's write this. The meaning of this one is p of 12 plus p of 13 and so on till which number? Till last one. You know there are 20 trials up to 20 values of the random variable 12, 13 up to 20. What is the probability of this? You know 20C12 into p, which is half raised to 12 into half raised to how much? It has to be 8. Sum of these two is always this, we know. Plus what we'll get here? 20C13. If you write this 1 by 2 raised to 13, and here 1 by 2 raised to 7, but this is always 20. till 20C20, this is 1 by 2 raised to 20 into 1 by 2 raised to 0. Okay, so you can find 1 by 2 raised to how much? 20 outside. What will get inside the bracket? 20C12 plus 20C13 and so on, finally 20C20. If you want, you can simplify further, otherwise that simplification is not important. This is your required answer. Right? What is important? What is X? What is number of trials? And what's the probability of the success? The eighth question, for a binomial distribution 6, half, that means you have number of trials 6. Probability of success is half, and therefore probability of Q is also half. Okay, show that when X is 3, mostly likely outcome. Okay, so that means what we show when X is 3, probability when X is 3 is most likely outcome means what is maximum. This is maximum. For what are the possible values of X? You know, your value starts from 0, then 1, up to 6. So out of this, when X is 3, this probability should be highest, maximum. So try this one, not difficult. You will immediately realize why when X is equals to 3, this is highest, because P and Q are equal. Just write the formula, you will come to know. Okay, so this I leave it for you. We'll go to next, 9th question here. See this. On a multiple choice examination with 3 possible answers for each of 5 questions. Okay, so the number of questions equals to 5. So have you realized number of trials equals to 5? What is how many possible options you are having for each question? 3. Okay. What is the probability that a candidate would get 4 or more correct answer just by guessing? Okay. So what is definition of success here? That is based on the question. So success X, that represent what it represent? Number of answers by just guessing, because that is what you are asked for, probability, answers by guessing. Okay, now for each question there are 3 options. So what's the probability of the success? Small p. For example, true, false and guessing, 3 possibilities, so it has to be 1 by 3. And it implies what is Q? It has to be 2 by 3, because we know here in a binomial distribution P plus Q is always 1. Fine. Either true, false or guessing. There are 3 options. Read the question, it is clearly written there. How many options? 3 options. So for one option, 1 by 3. Okay. Now what is asked? What is the probability that a candidate would get 4 or more correct answers? Okay. So therefore required probability equals to probability when X is greater than or equals to 4. What's the question? 4 or more answers. Fine. So here you know what are the possible values? 0, 1, 2 up to 5. Maximum is 5. 4 or more answers. So how do we write this? When X is 4 plus 5. Maximum is 5, because you have how many trials? 5 trials. So now just we place the value here. So what is this? This is 5C4 into probability of the success 1 by 3 raised to 4 into this is 2 by 3 raised to 1 plus this is 5C5 into 1 by 3 raised to 5 into 2 by 3 raised to how much? 0. So you know that this is just 5, this is 1 and so on. Simplify and check your answer. I will not do this because up to this it is important. So do it and check your answer. A person buys a lottery ticket in 50 lotteries. Okay, so he is doing trial for 50. n is 50. In each of this, so in a single trial, his chance of winning a prize is 1 by 100. So you must have realized this is the probability of the success. What is the probability that he will win a prize for these 3 sub-questions? So how do you define the success here in this question? Let success be here. Success, that is X. How do we define it? Number of prize winning lotteries, that is number of here prize winning lotteries, right? Fine. So X varies from where to where. What are the possible values of X? 0, 1, 2 up to 50. There are 50 lotteries. Now what is the probability of success? That is prize winning in a single trial, which is given to you. What is that? 1 by 100. It's given in the question itself. Probability that he wins the prize, which is 1 by 100 in each of this lottery, and therefore Q must be 99 by 100. Okay, fine. So you have N, you have P. X we have defined like this. Come to first question here. Required probability. I'm sure now you can do this because this is one of the simplest exercise. At least once. At least once means what? Here probability where number of prize winning lotteries must be more or more than 1. At least 1 means what? 1 or more than 1. Fine. So how do you answer this? One way is P of 1 plus P of 2 up to which number? Up to P of 50. But this is not the right way of doing. So we write this as what? 1 minus, it starts from 0. So when X is 0 here. And this can be answered very easily. How do you answer this? NCX, that is 50C0 into P. P is how much? 1 by 100 raised to 0 into Q. How much? 99 by 100 raised to, it has to be 50 here. So 1 minus, this is 1, this is also 1. So you have 99 by 100 raised to 50. Right? That's required probability here. Fine. No need to simplify this. Go to second sub question. Let's see that what it says. It says that exactly once. Exactly once means what? Now required probability equals to P when X is just 1. So this term only. Exactly once. So you have here 50 C1 into probability of the success 1 by 100 raised to 1 into 99 by 100 raised to how much? It has to be 1 is used, so this is 49. Fine. So if you just simplify a little bit, this is 50 C1 is just 50. This is 100, so this is half into 99 by 100 raised to 49. So you can just write here half into, this is half, 99 by 100 raised to 49. Right? That's your answer. Okay. What about third question? At least twice. How do you write symbolically? I'm sure now you are capable to write this symbolically. So here required probability equals to probability with at least twice, that is 2 or more than 2. At least twice means what? 2 or more than 2. So you will have either P of 2 plus P of 3 till what? P of 50 here. So that is same as here 1 minus what? P of 0 plus P of 1, that now. This total summation is always 1. So just place the value and simplify so that you can do very easily. Okay. Question number now 11th. Let's see. Now I'll just indicate here what is n, what's the probability of the success. You can also think. Find the probability of getting 5 exactly twice in 7 throws of a die. So how many times you are throwing? 7 times. The n is 7. You want the probability of getting 5. So what is the definition of success here? Let success be here x, that is number of 5. Number of 5 in trials. Okay, trials are independent here. What are the values of x? 0, 1, 2 up to maximum 7. Okay. What is the probability of the success? Small p. So my question is, what's the probability of getting 5 in a single trial of a die? That is 1 by 6. You know, right? These are the favorable outcomes. 1, 2, 3, 4, 5 and 6. So probability of getting each integer, that is 1 upon total 6. And therefore, what is q here? That is 5 by 6. Now, I think you are almost through. Just read the question. So immediately you can answer. What is the question? Let's read that. So required probability equals to, please read the question. What's the required probability of getting 5 twice? So number of 5, x should be 2 times. So p when x is 2. So just write the formula. What is the formula? 7c2 into p. What is probability of the success? 1 by 6 the whole raised to 2 into 5 by 6 the whole raised to, this is 5. Okay, now the question is you need to simplify. So simplify 7c2, you can find very easily. Place c and check your back side answer. Okay, now remaining 3-4 questions for you. Try it, I'm sure you can do. You ask for number of trials, what is success, and write the probability of success, which is p and q, and then just place the value. Try it, I'm sure you can do it.